Okay, today is still 17.2 complex numbers. We're going to call this day 3. It's sort of like yesterday it continued, except we are in a new section. Anyway, it's about converting between rectangular complex form to polar complex form. That's what you're learning. But let's just go back for a second and say, do you remember polar? You just did it. Do you remember polar form was a new way to graph things? You could do r comma theta. I'd like you to try to remember that for a moment by saying, where is this spot? Let's call it root 2 is my r. That's a strange r. But comma pi over 4. Where would that be? If you think about it, I bet you'll figure out why I used root 2 for my r. Think about that. Right, so the way I like to do them is figure out which direction am I going. Like if you were telling me to walk to a place, I'd rather have you tell me which direction to go first, and then I can start, and then you can tell me how far to walk, right? So the direction I'm going is pi over 4. You know which direction that is? Kind of like this. And I should walk that way for how far? Square root of 2. Well, that's more than 1, but it's less than 2 because that'd be like square root of 4, right? It's a little over 1, so I don't know how far that is. We'll say it's that far. And I put a dot there, and there's my spot. Raise your hand if you had the right place. Okay, good. Then what's the rectangular coordinates for that? Hint, if we know this is a 45-degree angle, also known as pi over 4, and we know this is root 2, then it won't be hard at all to figure out how far was it this way and how far was it that way. What was it? 1 and 1. Okay, because this is the 1, 1, root 2 triangle. Now I happen to make that one nice because I gave you a nice, easy r, right? What if it had been the square root of 7? Wouldn't have been so nice, right? All right, let's change it to that. If I make that the square root of 7, and now figure out, those aren't 1s anymore. I like to then have a helper triangle just sitting there ready to help me. All drawn in the same orientation as the other one. It would be 1, 1, root 2. That helps me to see what's really happening compared to the classic 1, 1, root 2 triangle. You agree this one's bigger because it's got a root 7 instead of a root 2? And we can say the scale of it is then root 7 over root 2. It's that much bigger. And I like to go this way. Root 7 is to root 2 like x is to 1. So x would be root 7 over root 2. Raise your hand if you had that one right. Okay, good. If that's my x, root 7 over root 2, and then the y would have to be what? Root 7 over root 2. Okay, good. That was converting between what and what? Polar and rectangular. Good. Now, what you need to learn is how to graph. This is important. How to graph complex numbers. Because you can't graph imaginary numbers. Well, how the heck are you going to graph a complex then if it's got a real part and an imaginary part? Here's how. If you got a real part and an imaginary part, let's say it's 2 plus I, and I'll put a 1 in there just to make it clear that that's some amount of I. Then there's a real part and imaginary part, but this part's real and so is that part. It's how many or how much of I we have. Technically, the only thing that's imaginary is the I part. So I can graph these two numbers. This guy, I think his name was Argand, not sure, but anyway, he's a mathematician, figured out, well, we could graph these just graph the real parts of it. And we'll say that the x is this part and the y is that part. And so you graph them x on the x-axis and yi on the y-axis. So if I was going to graph 2 plus I, I'd just go over 2 and up 1. Boom. Done. That is that easy. So if I wanted to graph 3 minus 2i, I'd just go over 3 and down 2. There. It's that easy. These are way easier to graph. So then what we get into right away is, instead of like last time we had to spend a bunch of time practicing graphing polar, we don't have to practice this. It doesn't be that easy. Okay, but of course we need to change it back and forth to rectangular coordinates, and then you take this complex graphing system and change it to polar. All right, so let's really dissect this one thoroughly. Would you agree that this distance right here is not 2 and it's not 1? Okay. This distance is 2 and that distance is 1. How long is that distance? Just use square root. Square root of what? Square root of 5. Good. Should be good at those by now. You have to square the x, square the y, put them together. All right. Then, if we're going to change this into polar, would you agree that that square root of 5 thing is important because it's the r? I got the r. All right. What do I need? I need r comma theta if I want to change it into polar. If I wanted to change it into rectangular, I'd already have it. It's 2 and 1. Okay, so the rectangular is super easy. But the polar is still the tricky part. I got to figure out that angle, and that is not one of the triangles that I have memorized. Therefore, you just go to this. It's r, comma, and the angle that you would want for this is this angle, and I do not have it memorized, so I have to go to tangent, but angles aren't given by tangent, but they are given by inverse tangents. Remember those? We do a lot of reviewing in this, which makes your final go a lot easier because we'll have reviewed what the heck an inverse is again. Okay, inverse gives you an angle. Remember that me saying that this is saying I want an angle because it already has the sides. We already have the sides, right? And we can get an angle from that. What are the sides involved with tangent here? 1/2. Tangent, TOA, opposite over adjacent, 1 over 2. There. I now have my radius, which I can replace with what? What's my radius here? Root 5, comma, the angle. It wasn't a nice one like 30 or pi over 6 or whatever. But I can say the angle by saying an inverse. I started with what kind of a number? Don't say imaginary. Complex. And I ended with what kind of a number? Polar. If it's got r and theta, it's a polar. Okay. But wait, there's more. If it was just that, we could be done right here. But there's another really important part, and that is you can write these in a different form. That's the form they usually write them in. And again, this is one of those deals where you put this in front of somebody on the street. Less than 0.5% of people will know what you are talking about if you say, oh yeah, it's 5 cis pi over 3. But you will, by the end of the hour, know what the heck that is. That's called r cis theta form. Okay? And now just think about it for a second. Would you agree that that has an I in it? CIS. So obviously it has to do with what kind of numbers? Don't say imaginary. Complex. Has to do with complex numbers, okay? But yet it's got an R in it, and it's got an angle in it, so it's kind of polar, because it's got an R and a theta, and it's kind of complex, because it's got an I in it. So it's a polar complex combo. All right, so R cis theta. It's not that bad, really isn't. So let me show you on this one where this comes from. So do you get from my picture here that my original thing, which was, what was my original? 2 plus 1i. I didn't use this one, I used the one I circled there. 2 plus 1i. That was, what kind of a number again? Complex. We can write that in this other form that's a R cis theta form. If we knew the R, we do know the R. What's the R? Root 5. It didn't just pop out at you by looking at 1 and 2, right? We had to draw a picture to figure it out. But we got the R. The R part was root 5. Then it's got this cis theta thing going on. Well, if I just had the theta, I could write this, and it'd be pretty easy if I only knew what theta was. But I do know what theta is. It isn't nice like pi over 6, but what is theta? Inverse tan of a half. There. It's the same as polar r comma theta, except it's got this cis in it. What the heck is that cis stand for? Oh, let me show you. It's shorthand for something. It's got an I in it. I hear people whispering cosine. What do you think? Cosine and I and sine. You are correct. You guessed it. All right, so now let me tell you what it means or what it does. And why do you care? Okay, so cosine I sine, CIS form. I think the easiest way is to say, would you agree that this came from x plus yi? That's what it was in the first place. And polar for x is what? R cosine theta. And polar for y, and don't forget it was x plus yi, right? So here's the y part. R sine theta. And if you can factor it, you should. R comes out. Cosine theta plus sine theta. And where's my I go? Put it right there. And there's where CIS comes from. Cosine I sine. Now here's how it actually works then. In my problem here, I had square root of 5 times cosine I sine, cosine plus. In fact, I like to even put a little plus in there. C plus IS, cosine I sine. You don't have to, but a lot of times people forget it's actually cosine plus I sine. And I'm just writing theta here, even though I know it's technically inverse tan of 1/2. But once again, my picture comes in to save the day. What is cosine of this mystery angle? I know it's inverse tan of 1/2, but if I just want cosine of it, it's right here. What's cosine of that? 2 over root 5. And what's sine of it? 1 over root 5. And because of how these are set up, this will always be the same as this and this. So when I multiply it in, it's kind of cool. It cancels, and I have 2 plus, multiply this times this. There it is. So I took root 5 CIS inverse tan of a half, and I, knowing my picture, the picture was huge, figured out what cosine, this was cosine, I sine meant, and it allowed me to take this form, which is complex rectangular form, because you get how it's got the 2 and the 1, and those are just the rectangular coordinates for it, and changes it to cosine I sine form. These are 2 forms for the same thing. So that is one way to write an imaginary, no, not an imaginary number, a what? Complex number. What's the other way? You have to be able to translate it from CIS form to the other form. What did I keep on saying was so important? Picture. Make a picture. Make a picture of this, and it won't be that hard at all. And also, there's a little plus in here. I'm going to pause for a second. I'm going to give that a try. All right, so did you have the right picture where my radius is root 2 and my angle is pi over 4? If you hopefully you know pi over 4 angle is a 45-degree angle, so it's going out there. And then I have a radius of root 2, and then, ooh, that looks suspicious to me. I think I remember this triangle. I do remember that triangle. It's the 1, 1, root 2 triangle, right? Could you have figured that out? Yeah, because we knew this was a 45. And you can back it up and figure it out. Even if that hadn't been a root 2, even if that had been a root 7, you know, like on the other problem, you could have figured out how long they were, right? Okay. Now, how do we finish the deal? Root 2 times cosine I sine of pi over 4. Do I have to really do all of that to figure out the other form of it? Nope. The answer I'm looking for is like 3 minus I. So, what's the answer? 1 plus 1 I. It's that, and then the I tacked on at the end. That's all there is to it. Could you have gone through and figured out cosine of pi over 4 plus I times sine of pi over 4? Yeah, you could have done that. That'd be the long, slow way. Picture's way faster. Square root of 2 times cosine of pi over 4, adjacent over pi is 1 over root 2 plus I times the sine of it. Sine is opposite over hypotenuse, 1 over root 2. And then I could multiply this out. That times that times that, and guess what? I get 1 plus 1i. There we go. Picture's faster. Picture's worth 1,000 words and lots of calculations. All right, so let's do one more like that. I told you it would work with any square root, so let's go with square root of 8. CIS, and let's do it this time with a pi over 3. Draw the picture. Draw the picture, it's going to be so much easier. I hope you drew a picture. And I hope you put it at pi over 3, which is a 60. And I hope you put it out some distance, which you called root 8. We really don't care exactly how long it is, but we'll call it root 8. Then I got to figure out how long these two guys are. Why do I care about them? Because they're my x and my yi. So if I could figure out this and this, I'll be home free. I won't even have to multiply the whole thing out. So I like to make the helper triangle. So I'm going to make it over here and say this is a 60 and that's a 30. It's a 1, 2, root 3. And then I can go, ooh, that's an icky combo. But I can still work it out. This is x, this is y. I can say root 8 is to 2. Well, it's bigger. As that is to that. X is to 1, and therefore x is root 8 over 2. Raise your hand if you had that one right. Okay, cool. And then the y is root 8 is to 2 as y is to root 3. So then I have to multiply both sides by root 3, and I'll end up with a root 3 here, and this one will go away because I'll have one there and it'll cancel. And then there's my answer, and that's a little icky, but there's my y. So your job was to find x plus yi form. It would be root 8 over 2 plus my y is root 24, which can be simplified, over 2i. There we go. And yes, root 24 is root 4 and, help me, 6. So then that would be 2 root 6, I think. Yes.
Like, how do you want us to, do you want us to simplify?
Yes. I just wanted to get to the end of the question, but I was going to rush through that, but I knew somebody would want to know, so. There you go. That's changing CIS form to rectangular complex, or complex rectangular form. Okay. Any questions? All right. Well, let's get to the homework. Everybody pause while I... All right. So, first off, we're not doing all of this. We'll do a bunch. All of the ones on the front page there. And then of these, looks like we're going to skip 18 and we're going to skip 20. On this page, I think we're going to skip all of those. Let me see how much further I want to go. That's good stuff. We need to do that, some of that. So we'll skip these. Don't need to do that. So we'll skip all of that. It wouldn't hurt you to do it, but. And then we'll go back one more, and I'll skip a little bit more here. We'll just do the circled ones here, so we'll skip that and that. I do want you to do number 29. So we're doing that. Okay, here's my tweak to make the assignment more reasonably sized. Now let's do some together. On the first page of it here, 9 plus 9i. My advice, draw a picture. You can solve a lot of these problems by just drawing the picture. It also helps you see if you really understand it. Over 9, up 9. Put a dot over there. Am I done? No. I got to find the r and the theta, and I'm going to allow you to skip all of these things, because if you've got a fully labeled picture, you got everything you need. Okay? The fully labeled meaning you got to have the r and you got to have the theta. All right. So then that's a triangle, of course, and the sides are 9 and 9, and you know that pattern, right? If you need to, go over and make a little helper triangle, 1, 1, root 2, right? So then how long is that? 9 root 2. Good. Okay, that's my r. And then what's my theta? Because it's this little helper triangle, I know which angle it is. Which angle is it? Pi over 4. So r equals 9 root 2, and my theta equals pi over 4, also known as 45 degrees. Okay? All right. How about this one? It doesn't have part of it. Oh, but it does. It's just a 0. Very good. 0 plus 6i. If I was going to graph it, I'd go over 0 and up 6. So pretty much just up 6. And then, but what angle is it? Well, you know these. What is that spot? Pi over 2. Good. So now you know the r, and you know the theta. That's all you need. R would be how far it is from there, and that's 6. And your theta would be pi over 2. All right. I am going to go over to this page and do, actually this is more of the same. Just got more complicated numbers because I throw in more negatives. But if you're going to graph that, you'd still go 12 negative, and then you go down 5. You just got to be more careful with your negatives. And they did 12 and 5 for a reason, because it's one of the Pythagorean triples. You know that one? 5, 12, 13. Good. All right. And then, oh, wait a minute. What if, I don't know that angle, but you can use inverse tan for the angle. Let's do one of those quick. If this is negative 12, and this is negative 5, and this is 13, then R is 13. But what's theta? It's an inverse tan. Inverse tan of what? Come on, here's the angle. TOA. Negative 5 over negative 12. Negatives cancel. 5/12. With me on that? Opposite, adjacent. Yes, sir. Ooh, interesting point. I get what you're saying. It's okay. I do remember, I know what you're talking about. That's no man's land, okay? But all we're trying to do is find an angle. And if I use my calculator and type in 5/12, inverse tan of 5/12, it'll work. Because do you get they're both positive, and it's like it's putting me back over here, since they're both positive, because the two negatives cancel each other out. I get what you're saying, though. But in this context, it'll work, and it's okay. Because all I want is this angle. I don't want that angle. That's kind of the reason. Is all I care about is that angle. Okay, let's move on. So, and then there's this CIS kind. So, what is 2 CIS pi over 6? Once again, draw a picture. Radius is 2. I'm going out 2, and I should do it at an angle of pi over 6. Here's my pi over 6 angle, and I'm going out 2. There it is. There's my picture. Does that answer all my questions? No, but I just need x and y now. So I got to figure out how long's that, how long's that. And this is one that I know. And hopefully it'll snap in pretty quickly that that's the 1, 2, 3 triangle. And you'll be able to find x and y pretty easy. All right. So what about that one? All right. Back to a picture again. If I have arctan of 4/3, do you agree that that means tangent of the angle is TOA 4 over 3? That's TOA, opposite over adjacent. Can I draw a triangle that has an opposite side of 4 and an adjacent side of 3? I certainly can. So here's a triangle that has an opposite side of 4 and an adjacent side of 3. So that's 4 and that's 3, and then I can figure out the r pretty quick, can't I? It's got to be 5, and it even has that right there, so that worked out pretty good. And then if it wants me to figure out the CIS form now, no, sorry, it's already got the CIS form. It wants me to figure out the x and the y of it. Your answer is going to be like 2 plus 3i, but it's not the answer. You figure out what the answer is. Once you got the picture drawn, these are easy. Okay. Let me check the key. I don't want to give you too much help. Probably already did. But all right, that's all I have for you for today.